Let's take a look at the output block. This is our window from the digital world to the analog world. And you'll notice the first thing is that there are only nodes on the left side of an output block. Therefore, we can go into an output block. And in some ways that sounds backwards, but once you realize that the output block is simply representing the digital to analog conversion, and over here we are in the digital world, so we're going from digital into the analog world. So let's open it up and take a look inside. There's the mute, which obviously stops the audio of that channel. There's a digital level, there is an invert of phase, and there is a full scale output. This part is actually one of the most powerful things that's in the bi-amp digital signal processors. This is allowing us to adjust the digital to analog converter and at what voltage it decides to make the conversion. Here's an example. In a normal sound system that's not even using a digital processor or using a digital processor, we will take all of our upstream things, and in our case here, our input gain, where we brought it up to 42 dB for a microphone, to make sure that our signal is reading right between 0 and +8, as we discussed in the very first video on gain structure. And at that point, our signal is traveling through our Nexia and is continuing on in a very solid, strong signal. And then as we get to the output meter, we once again are still reading about 0 dB for a normal signal. Well, that, when we convert it out to a comparable analog signal, is a lot of voltage. It's a very strong, nice, clean signal with our signal to noise ratio very high. In other words, our signal is well above the noise floor of all of our equipment upstream. And then therefore we hand that off to an amplifier. Now the amplification part of an amplifier is actually pretty simple. Whatever comes in, voltage-wise, is multiplied by a certain factor. And in some cases, that's too loud when it hits our speaker system and is converted to acoustical energy. So what we have on most amplifiers is a knob on the front, and most people will look at it and say, well, I'm turning up the amplifier. But if you look at it closely, all the way to the right is usually marked with a 0 or bypass, and all the way to the left is marked with a -infinity. It's actually just an attenuator. All the way to the left is maximum attenuation. All the way to the right is in bypass mode. It's just letting the voltage come through that's hitting the front end of the amplifier get to the amplification section. So in most sound systems, since we're sending a nice hot signal, we will turn that amplifier's knob to the left to create some attenuation to only let a certain amount of voltage get through to the actual amplification section. And that allows us to mitigate how loud the sound system is in the room. Well, if we go through in our digital signal processor and we have gone through and we've gone to our comp limiter and we've set a compression setting and a limiting setting and a threshold to protect our speakers, and then we turn that knob in the physical world, some well-meaning person could come behind us and turn that knob again, and that violates everything that we have set up inside our digital processor. Well, if there was a way we can move it inside our digital signal processor and it's under our password control versus leaving it outside for someone to mess with, that would be a good thing. And that's exactly what the full scale output is. It allows us to tell the digital to analog converter to convert the signal just at different voltages. It maintains the same signal to noise ratio, it maintains the exact same picture, it just creates it at a different voltage. Let's look at the nomenclature. When full scale output is at +24 dBu, that means that when we hit full scale digital, when we hit the top of the ceiling in the digital world, which in our system is +24 on all of our meters, that means in the analog world we're hitting +24 dBu. When we are at 0 dB on our digital meters, we are, quote, at 0 dBu in the analog world. Now, if we take and adjust this here to where the full scale output is reading 18, that means full scale in the digital world, +24, is plus 18 dBu in the analog world. In other words, 0 dB in the digital world is now plus or minus 6 in the analog world. So everything is down 6 decibels. If we drop this once again to where it's at 12, that means in the digital world plus 24, or the full scale, is equal to 12 dBu plus 12 dBu in the analog world. And once again, translating back to 0 dB, 0 dB in the digital world is now minus 12 in the analog world. And this continues down to minus to 6 to 0. And in the CS and the VC and the TC, you have the ability to even step down to where minus 31 is equal to the full scale output. And so therefore, about minus 55 is our level when we are running things at Unity, and this allows us to get into a true microphone input. But as you will learn to adjust your systems, and you'll find that this right here is one of the most powerful tools in setting up the gain structure in your system and protecting your system from tampering. Then what we can do is we can come here to the digital level and we can fine-tune adjust in tenths of a dB, and this is really good for matching up speakers and two speakers in a cluster, or between a main speaker and a subwoofer in between the 6 dB steps. But rarely would I ever adjust this more than 6 decibels. I would go over here to the full scale output and adjust that back into take care of those bigger jumps, and that gives us a nice clean signal, because that's just taking the digital converter to analog converter and adjusting how it creates the picture. This is actually adjusting the picture. This is, if I bring this down, it is bringing down my digital signal closer and closer and closer to the noise floor, and therefore my signal to noise ratio is more and more compromised. Well, that is about a quick look at the output block of the Nexia.